I'm Sam Booker from the University of Edinburgh. I'm a Simons Initiative for the Developing Brain Independent Research Fellow. And me and my team are examining the mechanisms of GABAergic inhibitory neurotransmission in the development of brain circuits in rodents and human brain tissue. There are many challenges associated with the research we're performing. The first is mainly how similar and different mammalian brain systems are, and how we can perform electrophysiology recordings in those different systems to try and understand what makes those systems similar versus what makes those systems different. So, for example, what makes a mouse brain versus what makes a human brain, and do the same rules apply to both? Me and my team are using a combination of wholesale electrophysiology combined with population-level recording and stimulation to identify how different cells' activity relates to the activity of cells in the wider population, to identify how their activity is shaped by the activity of other cells. The Scientifica equipment allows us to record a combination of wholesale electrophysiology and field recordings simultaneously in our system from up to 4 electrodes at the same time, whilst being able to perform state-of-the-art imaging, whether that's infrared or fluorescence imaging, from the same tissues, to be able to correlate function of single cells to the function of the population at the same time. Scientific equipment that we are using, principally wholesale patch clamp recording from up to 4 cells at the same time, allows us to perform extremely stable mechanically and optical recordings from populations of neurons in intact brain tissue. During the last 5 to 10 years of my research life, I have built up a strong relationship with Scientifica that has allowed us to develop together the electrophysiology systems that we use day to day. This relationship allows for the rapid repair and upgrade of our systems, as well as testing new equipment as it becomes available. My future research aims are primarily to bridge that translational gap between what we know in preclinical rodent models to what we can know using living human brain tissue. And this includes the establishment of cutting-edge slice culture and transgenic models of the living human brain. With Scientifica, I hope to establish new approaches, both using electrophysiology and fluorescence imaging, to allow us to interrogate the connections of the human brain in a way that we haven't been able to do so far.